Hello, welcome if you're new, welcome back if you're not. My name is Talia, and I'm a third year student at UCSD majoring in chemistry. I love making videos to help people with their chemistry education, and that is the purpose of this channel. This week, I am going to be continuing on in my equilibrium videos and talking about calculating K, or the equilibrium constant. Specifically, we're going to be calculating Kc, so we're only going to be working with concentrations, but in future videos, I will be going over Kp and maybe eventually Ka and Kb. So if you need help with that, feel free to keep on watching, and without further ado, let's get started. Okay, so let's get started. In the past video, I showed the same graph that's on the bottom right of this screen right now with an equilibrium reaction with the concentration of the reactants and the products and how they eventually plateau out to get to equilibrium. So K, or Kc, represents the ratio of the products and the reactants at equilibrium. So at this point, once they've plateaued. And it's crucial that you remember that K is for at equilibrium because there is another reaction quotient or a reaction constant that we will use, Q, and that is for initial conditions. But right now we're just working with equilibrium. So when you are given the conditions of, or when you're given the concentrations of your different chemicals at equilibrium, we can calculate K with the expression or with the equation that I've written on the screen. So if we have the reaction of W and X is in equilibrium with Y and Z with the stoichiometric coefficients A, B, C, and D, we can write our K expression as the concentration of the products over the concentration of the reactants. However, it's crucial that you raise the concentration of each product or reactant to the power of its stoichiometric coefficient. So you can see, for instance, that Y has the coefficient C, and in the K expression, the concentration of Y is raised to the power of whatever number C is. Okay, so there are a couple notes about calculating K. You will often be given the states in the reactions you're calculating K for. So it's important that we only include gas phase and aqueous phase chemicals in the K calculations. You don't include solids and liquids because the concentration of those is pretty much constant as the reaction continues to equilibrium. So they don't contribute to the change in the reaction constant. There are also ways to change the K value. If you change concentration or you change pressure or volume, you'll find that your K value ends up leveling out and going back to what it was. However, if you change the temperature of your reaction, you change the K value. And this depends on if the reaction is endo or exothermic, which we can relate back to Le Chatelier's principle. So in an endothermic reaction, our heat is on the reactant side of the equation. And if we increase heat, we're going to shift away from the heat term towards the right, or towards the products. And we know, I can't go back, but we know that the K calculation is products over reactants. So if we make more products, we increase K. And the reverse is true for an exothermic reaction. Because the heat is a product in an exothermic reaction, increasing temperature shifts the equilibrium left, thereby making more reactants and decreasing K. You might also be asked, which direction does your equilibrium favor based on what your K is? And the rule is that if K is greater than 1, your equilibrium favors the products, and if K is less than 1, the equilibrium favors the reactants. This is also having to do with the ratios. If you have a greater numerator than denominator, you have your equilibrium is going more towards the products and favoring that side, and the reverse is true. Okay, so now we're going to do some practice. So I've given you two reactions, and for each problem, I would like you to write the K expression. And given the equilibrium concentrations, which I've showed you, you're either going to calculate K, which is what the first problem is asking, or solve for the concentration of a specific chemical, which the second question is asking. The last part of the question is based on the value of K, does the equilibrium favor the reactants or the products? So take a moment to pause the video and work on those on your own, or if you need more help, you can just keep going and I'm going to go over it. but feel free to resume the video when you are ready and we'll go over the problems. Okay, so let's look at the first problem. We have 3I2 plus 6F2 is in equilibrium with 2IF5 and I4F2. And we have our equilibrium concentrations. There's 0.14 molar of iodine, 0.16 molar of fluorine, 0.036 molar iodine pentafluoride, and 0.020 molar tetraiodine difluoride. Oh, that is a long name of a covalent compound. Okay, so we're first going to write our K expression. We're going to do products, which are the IF5 and the I4F2, raised to their coefficients. I4F2 has a coefficient of 1, so I didn't put the 1 there. And then on the denominator, we're going to have the concentration of the reactants raised to their coefficients. Then we plug in the concentrations that we are given. And we get 5.6 times 10 to the second power. I did this because I wanted to have 2 sig figs because all of our concentrations are given in 2 sig figs. You could also write 560, that would work too. And because our K is greater than 1, our equilibrium favors the products. Okay, the second question, chlorine plus 2NO2 is in equilibrium with 2NO2Cl and has a K of 1.8. So this time we have our K, and I told you you're going to be asked to find the concentration of a specific chemical, which is NO2, and you're given the concentrations of NO2Cl and Cl2. So same thing, I'm going to set up my K expression. This time NO2Cl is on the numerator with the power of 2 because of the coefficient, and then on the denominator we have Cl2 and NO2, and that equals 1.8. So we're going to do some algebra. I plugged in the concentrations we have, and I didn't show all the steps of algebra. Feel free to ask me questions about that if you need, but you are going to solve for the concentration of NO2. Don't forget to square root it, and you get that the concentration of NO2 is 0.40 molar. Again, that is going to be with 2 sig figs. I also realized as I'm editing this video that I made a mistake with whether the second equilibrium favors the reactants or the products. The K is greater than 1, it's 1.8, so it will favor the products. So that is the end of this video on calculating K. I hope you enjoyed, and I hope that clarified the concept for you. In the next video, I'm going to be talking about calculating Q, which is basically K, but with initial conditions. So if you need some help with that, I hope you will join me back soon. Feel free to leave any comments or questions in the comment section below, and I will do my best to answer them. Good luck with learning chemistry.